Okay, let's look at this review problem where we are going to count the number of numbers that are between 10,000 and 99,999 that are multiples of 3, 5, and 7. To do this problem, before we get started, I'm first going to make a little diagram here to count the number of numbers in each category. So, for example, in this first column, there are 99,999 numbers that are between 1 and 99,999. How many of them are multiples of 3? Well, for that, I'll just use my calculator. So 99,999 divided by 3, there are 33,333 numbers in this range that are multiples of 3. To find the multiples of 5, I'll do the same thing except dividing by 5. So that number divided by 5 is 19,999. Okay, in other words, if I take 19,999 times 5, that is less than 99,999, but if I go 5 more, then I'm going to go past that number. So there are 19,999 numbers in this range. Next, continuing on with the chart, and I forgot to write this down, multiples of 7. So let me just squeeze in a line here, multiples of 7. Okay, this is going to be small print, but we can live with that. 99,999 divided by 7. There are going to be 14,285 numbers in this range that are multiples of 7. How about multiples of 3 and 5? Well, a number is a multiple of 3 and 5 if it's a multiple of the least common multiple of 3 and 5. And since 3 and 5 are both prime numbers, the least common multiple is 15. So 99,999 divided by 15. There are 6,666 numbers in that range that are multiples of 15. If I divide by 3 times 7, that's 21. There's 4,761 numbers in the range that are multiples of 21. Continuing on with the chart, multiples of 5 and 7, 99,999 divided by 5 times 7 is 35. That works out to be 2,857. And finally, multiples of 3, 5, and 7. Well, 3 times 5 times 7 is 105. So I'll divide by 105. And there are 952 numbers between 1 and 99,999 that are multiples of 3, 5, and 7. And I can just multiply 3 times 5 times 7 because all 3 of those numbers are prime numbers. Okay, now the question asks for not numbers between 1 and 99,999, but between 10,000 and 999. So I'm going to figure out the same thing, except between 1 and 9,999, and then I'll subtract. So there are 9,999 numbers between 1 and 9,999, and I'll just the exact same logic. So if I divide by 3, there's 3,333 of them that are in this range. For multiples of 5, divide by 5, there's 1,999.8. So I don't worry about the 0.8. Divided by 7, there are 1,428 numbers that are multiples of 7. If I divide by 15, I get 666 point something. 9,999 divided by, next category is multiples of 3 and 7. So divided by 21, I get 476. Divided by 35, I get 285. And finally, dividing by 105, we get 95. So once again, the interpretation of this last number is if I take 95 times 105, I get a number that is less than 9,999. And if I go 105 higher than that to the next multiple, I'm out of the range. Okay, so now I subtract. So 99,999 minus 9,999. Clearly, that's 90,000. Clearly, if I subtract these two numbers, that's 30,000. Next one, let's be careful on the arithmetic. 19,999 minus 1,999 is 18,000. So there's 18,000 numbers in this range. Next category, 14,285 minus 1428. There's 12,857 numbers in this category. Continuing onward, 6,666 minus 666. Clearly that's 6,000. Next category, 4,761 minus 476. That works out to be 4,285. Next row, 2,857 minus 2,085. That works out to be 2,572. And finally, 952 minus 95. There are 857 multiples of 105 between 10,000 and 99,999. Okay, now before we start answering the questions, so how many are there in this range, let's make our Venn diagram. So down here I've charted out my Venn diagram that I'll put the numbers in. And I'll start with the bottom rows. There are 857 numbers that are multiples of 3 and multiples of 4, and multiples of 5 and multiples of 7. Okay, now there are 6,000 numbers that are multiples of 3 and 5, 857 that are multiples of 3, 5, and 7. So if I subtract, I'll get the number that goes here. So 6,000 minus 857 is 5,143. Okay, next we have 4,285 are the number of things that are multiples of 3 and 7. So the number that goes here is going to be 4,285 minus 857. So 3,428. And that's a 4, so let's try that again. 3,428. Next, 2572 is the things that are both multiples of 5 and 7. So 2572 minus 857 is equal to 1715, and that's the number of things that go in this part of the Venn diagram. All right, next, there are 30,000 numbers that are multiples of 3. So coming back over here, the things that go here will be 30,000 minus 5143 minus 857 minus 3428. And so that works out to be 20,572. Okay, next, the multiples of 5. We've established that there are 18,000 multiples of 5 in this range. So coming back down here, 18,000 minus 5143 minus 857 minus 1715 is 10,285. And then lastly, we have 12,857 multiples of 7. So coming here, that's 12,857 minus 3428 minus 857 minus 1715, and so there's 6,857 numbers in this range. Okay, so there's our Venn diagram for now. I'll make one small alteration to this picture when I come up to near the end of the problem. Okay, so let's now turn to the problem. First part of the problem says, find the number of integers that are divisible by at least one of 3, 5, and 7. Now there's two ways of doing this. The first way of doing this would be to simply use the numbers that I see here. So this would be the number of multiples of 3, multiples of 5, multiples of 7. Then I would subtract off these 3 lines, taking the intersections 2 at a time, and then add on the intersections taking 3 at a time. So if I just simply do that, if I have 30,000 plus 18,000, let's get the glare out of the way, plus 18,000, plus 12,857, then minus 6,000, taken two at a time, minus 4,285, minus 2,572. So these are the three ways of taking them two at a time. Then the one way of taking them three at a time. And add them all up, I get my answer. So my answer for part A is going to be 48,857. And that's one way to do the problem. Another way to do the problem would be to simply directly count what I see here. So if I just take all of these numbers and add them up, I should get the exact same thing. So let's do that again as a check of our arithmetic. 20,572 plus 5,143 plus 10,285, that's the top three numbers. Then I'll take these three, plus 3,428 plus 857 plus 1,715. Then the last number is 6,857. When I come out the other end, my answer should match what I see here, 48,857. And so it does. Okay, so either way would be to do the way to do part A of this problem. Part B. The number of things that are divisible by 3 and 5, but not by 7. Divisible by 3 and divisible by 5, but not by 7. That would be this part here of the picture. So the answer is there's 5,143 numbers that meet that criteria. Next, divisible by 5, but not by 3 or 7. That would be this part here. It's divisible by 5, but we're outside the 3 circle and the 7 circle. So the answer would be 10,285. Lastly, divisible by none of them. Well, the way to do this, there are 90,000 total numbers that are between 10,000 and 99,999. There are 48,857 in these three circles. So if I subtract, so 90,000 minus 48,857, that works out to be 41,143. So that would be the number of things that are in the range but lie outside the three circles. So my answer to D would be what we just got, 41,143. Didn't write that right. 41,143. And the answer to part A is what we got over here, 48,857. And so that would be the way to count this problem using a Venn diagram.